Now, in this week's topic, we are talking about searching and sorting data. And as you may recall, we said that when searching for something, it makes it much easier once it's already sorted. Now, there are several sorting techniques. Often, when we sort things, we have them in an array. And remember, when we have an array, we start off at subscript 0, 1, at 2. Note, we have 8 elements in this array, and we have them all. It's pretty obvious that all of these are currently not sorted. Now, I'm going to demonstrate how it would actually work with the bubble sort technique, which is the first one we're going to talk about. Now, with bubble sort, what it basically does, it, unlike us, cannot see the entire list at the same time. It has to go through, it can only look at one comparison between 2 elements at each time. And the algorithm for the bubble sort says, compare 2 items, put those in the appropriate order, go through the entire list. If you have to swap them, you have to go through the entire list again. So when I start off at element 0, and I now look at 95 and 47. It's quite obvious that if we are putting this in ascending order, 95 is greater than 47. So what we do is we take a copy of 47, and we have a temp location down here where we take 47, we have to put it in the temp location, okay? And I'm going to say swapped is now on because of the fact that we're going to make this swap. I move 95 over to the appropriate location. I take the temporary moved value and put it in the first location, or location 0. Then as the computer, I go and look at the 2 here. Obviously -2 is not greater than 95. So this goes into the temp location. And I move 95 over here. Okay. And then we're okay. Swap's still on. 95 is greater than 14, so we move 14 to the temporary location, move 95 to the new location. And swapped is still on. We go 95, -5. Now we move these, swap them again. 95, 123. Hey, finally we got one that we don't have to move, but swap still stays on through our pass through this. Then we have 73 and 123. Put this in the temp location, move this over, move this up, and then we compare these two. 75 goes down to our temporary location, and 123 moves up here, and then 75 here. Now note, we are currently not in order yet. We've only went through on one pass, so we're going to turn this swapped off, because since it's on, we have to go through the entire list again. So we come back here, take a look at our numbers, and we say, yep, -2 is definitely less than 47, so -2 goes into the temporary location. We now turn swapped to be on. Move, whoops. Move, easy for me to say, 47 over and -2 here. And we look at 14 and 47. Yep. And then this goes here. And then 47, -5. Yep, moving away here. -5 moves down here. 47 moves up. -5 moves down. And here we're good. Here we're not good, so 73 comes down. 95 moves up. 73 goes up here. Go to these two. Okay, 75 comes down. 95 moves up. 75 moves here. And now we do 95, 123. Those two are looking good, but do we need to do the next round? Well, is swapped on? The answer is yes. So I now turn swapped off. Go back to the start of my list. -2, 14. We're good. 14, -5. Not good. So we put this down here. We turn our swapped back on again. Move this over. Move this here. Compare, 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 compare. Let's see if a swap, yep, swap is on. So we're gonna turn it off and run through it again. So, whoops, these aren't in the right order. So we go back, move this to our temporary location. Move this back to here. Move this here. Okay, so swapped is now on. So we're still good, still good, still good, still good. Okay, okay. And since swapped is on, we have to recheck the entire list, so I'll turn it off. And start again. We're good, we're good, 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 good. And now we have a sorted list. Now note, the difference between ascending and descending is pretty easy to see. Instead of with 8 elements, if we start at 0 and go up to one less than 8, which is 7, we do the ascending order. If we start at 7 and go down to 0, then we would print them in descending order. If you noticed our list of numbers in the semi-random order that they were in, it is very time consuming with the bubble sort to actually go through and process it. That's why the bubble sort is not very efficient when it comes to large amount of numbers, but it becomes very nice once they're sorted because I can look at my least value compared to my highest value very, very quickly. So I hope this demonstrates how to use the algorithm of the bubble sort. In class, normally we would actually pick numbers and sort together walking through this, but I'm hoping this will kind of demonstrate it a little bit easier. All right, now we demonstrated how we would use the bubble sort, and we noticed how kind of inefficient it was at sorting things. So we're going to go the next step up, which is called the selection sort. And part of the reason why people are not quite as comfortable with the selection sort, I think, as they are with the bubble sort, is because the bubble sort is really easy to see the logic in it. Selection sort, when you see the code and the algorithm, it's a little more sketchy until you actually see it demonstrated. And so we're going to go ahead and demonstrate it with that same list of array elements that we had before. Now, with the selection sort, what we do is we take a copy and we start off with what the current lowest number is. And since this is pass number 1 through, our current lowest value is 95. Now, we don't move that value, we just basically keep track of it. And what we do is we compare each element to that. So the current low value is 95 at location 0, because we're starting off. Now, so I'm going to take our current low value, 95, and I'm going to compare that to 47. And yes, if we had an audience here, they'd all be saying 47 is lower. So we would go here, scratch out the 95, and put 47. And that currently is at index number 1. Then we move on to our next one, which is -2. Well, -2 is definitely lower than 47. So we've got -2, and that's at index number 2. And we look now at the next one, which is 14. And it's not less than -2. Then we come to our next one, which is 4 at -5. Well, that definitely is lower. So we're going to put -5 here at index location number 4. And then we go to the next value, which is 123. That's definitely not lower than -5. 73, which is also not lower than -5. 75, which is also greater or not lower than -5. So we have our selected value. Now what we basically do is, since this is the first pass through, we are going to take whatever element is in the starting location. We're going to move that to our temporary location now. And we're going to take the value that is at index 4 and put it over here at location 0. And now we're going to move the value 95 to where that lowest location or lowest value was, into that location. So 95 takes a quick move right up here. Now now we've gone through all 8 elements. We've selected the lowest one. And now we are going to start our list at location number 1. So our current low will be 47 at location 1. Next one, well, definitely -2 is lower. And that's at location 2. So -2 at location 2. We look at 14 in comparison to this, 95, 123, 73, 75. They are all greater than -2, so we've gotten through the entire list now. We say this is our lowest one. So what we do is we put 47 in the temporary location. and we move -2 to location 1. We move 47 to the index that the lowest value was at. And then, instead of starting here, we start here. So we're now going to say, okay, we have 47 at location 2 as being our lowest value. And then it next gets superseded by 14 at 3. And 14 at 3 remains the lowest value as we go through the list. So we basically say, okay, 14 goes into the temporary location. 47 moves to where that one was. And now we start here. So we start it at 3, and we say, okay, 47 at location 3 is our lowest value. Now that's still lower than 95, 123, 73, or 75. So actually it got moved relatively quickly into the space that it's going to be its resting place. So we move on up to start here. Note each pass that we go through, the less number of comparisons that we have to do, and basically our list gets shorter. So our next time through here, we're going to start off with 95 at location 4. 123 remains there. 73, it now changes to 73 at location 6. And 75, okay, this is our winner. So we take this and put it in our temporary location. We move 95 to the location it was at. We put that here. And note, now we start here at this list. Now note, as I said, we go through, we have much less to compare and sort with. So, and note, we only swap once each round. So here we have 123 at location 5 of our lowest one. 95 is lower than that, so we switch to 95 and 7, or I'm sorry, 95 at location 6. And then we have 75, which is lower than 95. I was getting ahead of myself at location 7. And so we put the 75 in the temporary location. We move 123 to the location that it formerly held. And then we come here. Now note, we then start here between these two, and we have 95 at location 6 is our lowest one. We're still good. So no swapping has to happen, and that means it only took the 7 passes to get the 8. But notice our list kept going shorter each and every time. So that's how we basically go ahead and do a selection sort as opposed to a bubble sort. If you notice, once again, that my moving things to the temporary location and moving things around was much less, and the number of comparisons was much less for each pass through. So that's why the selection sort is much more efficient in general than the bubble sort. I hope this quick demonstration has given you a little bit better understanding in how we apply both the bubble and selection sort.